Alright, so we're continuing on with a few more examples showing you how to find the area and perimeter of 2D shapes when things might not be given to or things are kind of hidden. So let's look at an example of a trapezoid. Like I had said a few times now, take a second to pause the video if you kind of need to catch up with us in terms of the drawing and getting everything labeled appropriately. Make sure there's a 90-degree angle there. The height is 2 feet. This top base up here is 3 feet, and this whole bottom down here, we're going to call that base 2, because when we look at the formula for a trapezoid, let's quickly look at this here, it's 1/2 the base 1 and the base 2, and it doesn't matter which one is the base, or which one is base 1 and which one's base 2. I always call base 1 the top one and base 2 the bottom one, but it really doesn't matter. And then just like the base and the height with a triangle where they have to be 90 degrees to each other, the same thing is true about the bases and the height of a trapezoid. So let's really look and see, how do I find the area? In this case, I wouldn't be able to find the area, so we're gonna mix it up a little bit, and I'm going to tell you that the area is 8. So there's a lot going on here. I gave you the area, and in this case, I want you to tell me, what is B2? What is that value? What is that second base value? So let's really dissect it. I always think it's important to write out the formula and then plug in what we know. And I'm going to try and use a few more colors to really help us out here. So base 1, that's our 3 feet right there. We're going to plug that in. I also know what my height is. I know that my height is 2. And then I also know that my area is 8. And I'm going to plug in everything that I know. So my area is 8. My base 1 is 3. My base 2 I don't know. You can leave it as a B or B2. That's what I'm going to leave it as. And then my height is 2. And you're just going to take a little bit to solve that algebra problem. So in this case, I'm looking for B2. I'm trying to get that by itself. I can multiply a few things together. For example, I can multiply these in any order. So I'm going to multiply the 2 and the 1/2 together to get a 1. That's B. Well, that's 3 plus B2. Oopsies. So I just multiplied those two things together, 2 times 1/2. Because that's multiplied by 1, I don't actually need that there. I'm just going to rewrite it without it. And then my last step would be to subtract 3. So B2 is 5 feet. Please again, make sure that you're labeling everything. That's how you do one problem where if I don't give you all the sides, but I do give you the area, you need to be able to work your way backwards. And we're going to do one more problem. So example 3, why don't you draw yourself a rhombus? This is a very bad rhombus. It doesn't look like a rhombus, but I'm going to say it's a rhombus, and that's all that matters. And I know that the area of the rhombus is 20 feet. I also know that that diagonal, we're going to call that diagonal 1. I know that that diagonal is 8. And this diagonal right there, diagonal 2, is x. And that's what we're going to look for. I'm asking you to find what x is, or what diagonal 2 is. So I come back to my formula sheet, and I know that my kite is 1/2 whatever the diagonal 1 is, whatever the diagonal 2 is. So my area is 1/2 diagonal 1 times diagonal 2. Let's plug in what we know. For example, I know what diagonal 1 is, but I do not know what diagonal 2 is, and that's what I'm looking for. I also know what my area is. I know that it's 20. And in this case, just like before, we're going to solve for what we don't know. I can simplify things on this side. I could technically just jump right into dividing both sides by 8 or multiplying both sides by 2, but I'm going to combine these first. And my last step is to divide both sides by 4. So if I'm looking for x, or I'm looking for my diagonal 2, I know that it is 5 feet.